In this class, we will start with a new section of the chapter Light in class 10, okay, science. We have completed in the first part of the chapter. There are two parts of this chapter. As we know, the chapter is light and there is the subtopics called reflection and refraction. Reflection we have completed, and now we are starting with a new subtopic called refraction of light. So let us see this. Pause the video and write down this question. Come and rejoin, okay? Now what is these terms here that are there? So let us discuss that. Answer for this. For that, let us draw a diagram here. Let us say we have here second medium. Let us say this is a water, transparent water. So this is water. Please draw it. Okay, water, and this is the second, okay, second medium. That means we are going to pass light ray not into this, but first above it, and this is nothing but air. Above it is air, and this is the first medium. First medium. So pass a light ray. We know the light ray can travel in air, so you pass it up to the surface of water. Now here, as you pass it here, okay, as you pass the light ray like this, obliquely, okay, not perpendicular but obliquely, means bending, making inclination. So this first ray that is passed, we know will be called the incident ray, right? So write that one. As we know, the point of separation between the first medium, air and water, that line that separates, this one is called the interface, okay? Interface, you can write it down. Now in the case of mirror, in reflection we have seen that when the light ray strikes the surface, it doesn't penetrate the mirror, but instead it reflects back, bounces back. But in this case here, when it strikes the interface, even the second medium allow light to travel through it. So instead of bouncing back, it will enter the second medium. But before that, here, at this point where you strike the interface, this point is called the point of incidence. Okay, so here you draw an imaginary line exactly at that point, making 90 degrees to the surface, okay, 90 degrees to the interface. Such a line is called, you can write it down, such a line is called normal at the point of incidence, okay, normal at the point of incidence. So here, okay, sorry, normal at the point of incidence. So here, at the normal at the point of incidence, here, this one, this point, it will enter the second medium. So as it enters the second medium, you will notice that the light ray, instead of going straight, if it had gone straight, the light ray should have gone like this, broken rays, let us say. But it doesn't travel like that. It will bend towards this normal. It will get bent like this. This ray that has bent here is called a refracted ray, okay, refracted ray. Write it down. Okay, now here. So we have done here this one, and the angle between these two here, see, this refracted ray and the normal, this is called the angle of refraction, and the angle between this incident ray and this normal is called the angle of incidence. So let us write the definitions now, having understood this. A, refraction of light. So you can just write that one. You can write down the phenomenon of bending the phenomenon of bending of an incident ray as it enters, you can write along with me, as it enters okay, obliquely, obliquely, means the ray has to, incident ray has to enter like this, making an angle, not perpendicular. Perpendicular means this is not oblique perpendicular, so you have to obliquely pass it. Okay, so that is important. Obliquely from one optical medium, from one optical medium, from one optical medium into, okay, from one optical medium into another. As in, that bending is called refraction, okay, or refraction of light. It's called refraction of light. So here, the medium in which the first ray is passed, the incident ray is passed here is called the first medium, and the ray where it bent, and the medium in which the ray got bent, means where the refracted ray is called the second medium. Okay, now here B, second point is incident ray. So in terms of refraction, in terms of, we have understood, now we're writing the proper definition, so you also write along with that. Okay, in terms of refraction, the light ray passed obliquely, okay, the light ray passed obliquely, okay, or passed obliquely through the first medium, through the first medium, okay, through the first medium, and obliquely through the first medium, striking the interface. This ray will striking the interface, that means the surface interface between the first and second medium, is called the incident ray, is called incident ray. Okay, so that is the second one. So A is defined, B is defined, we have already understood, and we're writing the proper definition of these terms here in refraction. Now the next point here is C, the refracted ray. So we write there, the ray which gets bent, the ray which gets bent, okay, the ray which gets bent in the second optical medium. This happens in the second optical medium. As you can clearly see in the diagram, the bending is not happening in the first medium, but here see bending is happening in the second medium, water. This happens when S an incident ray is passed, okay, as an incident ray is passed obliquely through the first medium, is called refracted ray. The ray which gets bent in the second medium, okay, this happens when the incident ray is passed obliquely in the first medium. The one which gets bent is called refracted ray. Okay, then next point, D, here, angle of refraction. So that is the angle, okay, the angle between the angle between the refracted ray and normal at the point of incidence, is called angle of refraction. It's important to get these terms clearly before we go into the main part of the chapter. Okay, so this is question number 1. So the angle between this refracted ray and the normal at the point of incidence, this imaginary line, this angle is called angle of refraction. Okay, let's go to the next question, 42. Next question is 42. Let us see what is it. Maybe the question for us. Define normal at a point of incidence. Okay, normal at a point of incidence. This shouldn't be hard. Define normal, write on along with me, at the point of incidence in terms of refraction. So we have to define this in terms of refraction, because normal at the point of incidence is also there in reflection. That is different. Okay, so here an imaginary line, we have already understood that, so we can write the definition. An imaginary line, okay, an imaginary line drawn perpendicular to the interface, drawn perpendicular means 90 degree, perpendicular to the interface between the first and second optical media, okay, and then optical media at the point of incidence, at the point of incidence is called normal at the point of incidence. Okay, so here we can draw so many perpendicular lines like this on this interface, means the boundary between first and second medium is called interface. So many of them, but the perpendicular line that is drawn through the point of incidence means the point at which the incident ray touches the interface. Exactly there, if you draw a perpendicular, that is called normal at the point of incidence in the case of refraction. Okay, so next, 42 done. We have done 41, 42. Let's go to 49. Next is 49. So question number 49 is, let's see, what is this? These are all on your tuition note. Even if you don't have, you can write it down by following this same thing. 49. Okay, why does refraction take place? So that is the next question. Why does refraction take place? So just now we learned that when a ray passes from one optical medium like air into water, it gets bent, means refracted. Why do it bend? This question is asking. Let's write the answer first, and explanation is quite simple. Speed of light is different in different optical media. Speed of light in different optical media okay, optical media are different. They are not same, are different. So because of this, what happens is this. So when a light ray enters from one, so when a light ray enters from one optical media into another one optical media, from one optical medium into another, this is the reason, okay, into another, its speed suddenly changes. Its speed, and the speed of light suddenly changes, means suddenly increase or decrease, okay, depending on the two medium, okay. Oh, this causes the light ray to get bent. This causes the light ray to bend. This causes, so this is the reason, causes the light ray to bend, okay, to bend. Thus refraction takes place. So thus, this is the reason refraction takes place. See here, this is glass, let us say. Okay, you can draw it also as a rough, not necessary to give in the exam. Second medium, medium 2, and here this is above it is ear, medium 1. So let us raise and entering from ear to glass, and this border is called the interface, right? Now here, if you at the point of incidence, if you draw, just now we learned an imaginary line perpendicular to, that is called the normal. So the speed of this light is very high in ear, but when the same ray enter glass, we know that the speed of light in glass is quite slow, so lesser. So because of the sudden decrease in speed, it will bend towards the normal. So the reason why it bends is the speed of light in ear is so fast and it changes, becomes very slow suddenly in glass. So the reason is because of the speed of light being different in different media, which causes sudden change in speed, and the sudden change in speed is causing it to bend, just like sudden brakes to a fast moving car causes the car to bend, right? So that is the reason. Okay, now we're going to study the next question, 49, then 44, 3 more is there. We'll go to 44. Let's see what is it. Okay, so 44. Let me read the question. So we write this one first, okay? It's in the form of a true or false format. So S and incident. This is important to keep in mind. Incident ray enter from a denser, into a rarer medium, it bends away from the normal. It bends away from the normal. This one we need to keep in mind. No, away from the normal. So full stop here you put. So the angle of incidence, the angle of incidence, which is represented by small I, is smaller than angle of refraction, is smaller than angle of refraction. It's smaller than the angle of refraction. So as it enters from a denser into a rarer medium, okay, denser into a rarer medium. So for that, you see here. So this yes or no we're going to see. So below that you write this diagram for you to understand yourself. Once you understand, we don't need to draw that diagram in exam. For now you draw for your own sake. So here this is, let us say, glass. You draw it there, glass. Here we're going to take glass as the first medium, number 1. And then above it is ear. We're going to take that second medium. Meaning we're going to pass the light ray from glass first into the ear. That's why it's called first medium, and the ray is coming out in ear, so it's called second medium. Okay. Now here, always denser, rarer is a term that comes when we compare two different media, okay, different optical media. So here glass is denser. So for now we just, and this ear is rarer compared to glass, ear is rarer, and compared to ear, glass is denser. Now the term here denser simply means light ray will travel slower in glass and faster in ear. So meaning of rarer means light ray travel faster there. Denser means the speed of light is quite low there. Now when you compare glass, please keep this in mind, to another substance, glass may become rarer, okay? So it's a term we put after comparing with what is the second medium we're taking. So here you pass a light ray. Let us say you passed here a light ray. So just pass it. So this is the first ray you're passing, means this is the incident ray. So incident ray is in the glass. Now where it touched the interface here is called the point of incidence. There let us draw the imaginary line perpendicular to the interface, means it is the normal. Draw that. Okay. Now if this ray here, incident ray that is passed in the first medium, do not get bent, then it will continue in this straight path that you can draw. Broken ray means the straight path it would have traveled if there was no refraction. But here the speed of light is slow in glass and suddenly coming out in air, so speed will suddenly increase, so it will bend away from this line normal like this to the left side of the straight dots here, and that is called bending away. If the ray bends like this, then it is towards, but in this case the light ray is entering from denser to rarer, so speed suddenly increase, therefore it bend away, and so this is what happens. So this is the refracted ray. When you pass a light ray from a denser to rarer medium, always the refracted ray bends away from the normal. Now here this is called, because of that, this is called the angle of incidence, the angle between normal and the incident ray, and this is called the angle of refraction, the angle between this incident ray, this refracted ray and normal. So because refracted ray bend away from the normal, you will see that if it did not bend away from the normal, then the normal here, then here straight line like this, incidence and refraction will be equal. The angles will be equal because they are vertically opposite angle. But because it bend away from the normal, angle of incidence will be smaller than the angle of refraction. Is smaller than the angle of refraction. So let us read once. An incident ray enter from a denser into a rarer medium. It will bend away from the normal. Second point, because of this bending away from normal, so the angle of incidence is smaller than angle of refraction, or conversely, angle of refraction will be greater than angle of incidence. So this is yes. So we have understood. So please keep this in mind. Any ray entering from denser to rarer medium, the refracted ray always bend away from the normal. Okay, and the opposite is true. When it enters from rarer to denser medium, it will bend towards the normal. From denser to rarer, then the refracted ray bends away from the normal. From rarer to denser, then the refracted ray bends towards normal. These 2 points should be very clearly kept in our mind because we'll be needing it in the next classes. Okay, so here 44 is done. So let's go to 45. So 45 here, question number 45. Let us see what is it. Here, an incident ray. Next one, an incident ray enters from a rarer, this is the opposite of what we've done just now, rarer into a denser medium. Okay, denser medium. As an incident ray enters from a rarer into a denser medium, it bends towards the normal, okay, and the first part of yes, no, then full stop. So because of this, so the angle of incidence, which is represented by small I, is greater than the angle of refraction. The angle of refraction represented by small r. This is also another part, yes or no. So we are discussing just the opposite of what we discussed in 44. Okay, so let us draw below this a diagram again. This time it is from a rarer into a denser medium. Previous one was here from rarer to denser. Previous was denser to rarer. Okay, so now let's just take the first set of medium. Here this is glass, and this time glass will be the medium 2. Previous one glass was medium 1 because we're passing light ray into glass first. Now we're going to pass it through air first, so that is medium 1, and this is, even in the previous case, air was rarer compared to glass, which was denser. Previous case was from denser glass to rarer we passed. This time from air rarer into denser we're going to pass. Okay, so let us pass a light ray. For us to see this, we have to pass the light ray not perpendicular but obliquely like this. So this is the incident ray. So let us write that incident ray. And the point where it strikes the surface of the glass is called the interface. So that point is called point of incidence. There, at the point, exactly at the point of incidence, we draw an imaginary line 90 degrees to the interface. So that is normal at the point of incidence. We know that. So as this light ray enter from rarer medium air into denser glass, we will observe the exact opposite. Now, if it did not bend, the light ray would have gone like this. So you draw that broken lines representing the straight path of the incident ray. But because it is entering from rarer here into denser, suddenly it is traveling very fast in air, and in glass it's denser, means the speed will suddenly decrease. So it will bend like just like a car putting brake. It will bend towards the normal. Away means on the right side, but towards means on the left side of the straight line. Like this, towards the normal it will bend. So this is the refracted ray. So because of this, here this is the angle of incidence between incident ray and normal, and this is called the angle of refraction between normal and refracted ray. Because it's bent toward the normal, because of that the angle of incidence is greater than the angle of refraction. You know that, right? So here yes, and here yes. Okay, one more question before we complete. That is the 50. This is just yes, no type of question, but these are very important. That's why we're discussing. Question 50, the last question. Let's go and see what is that. 50. Okay, this one also we just primarily needs to write it, I think. Since the, write it down along with me. Since the speed of light is higher, speed of light is higher in a rarer medium. We learned that just a moment ago. Rarer medium, the speed of light is always higher in rarer medium and slower in denser. We'll discuss that, right? Medium, then a denser medium, then a denser medium. This is the reason why we observed the previous two phenomena. Okay, denser medium. S, because of this reason, Sn incident, as an incident ray, enters from, incident ray enters from a denser medium, a denser medium, in its speed into a rarer medium, denser into a rarer medium. Its speed suddenly increases, right? Suddenly increases, causing it to bend, causing it to bend away from the normal, away from the normal. So this is the reason why it is bending away from the normal. Yes or no? Just write like that. And right here, yes. So we learned in the previous section that when the light ray enters from a denser into a rarer medium, not this one, denser into rarer medium, it bends away from normal because the speed of light suddenly increases in the rarer medium. We learned that the reason is because the speed of light suddenly increases. So this is yes. Okay, so today we learned primarily phenomenon for refraction and the reason how it bends as it enters from one medium into another medium. So before we end the class once more, when a ray enters from a denser into a rarer medium, it bends towards the normal, okay? And when a ray enters from a denser into a rarer medium, the ray bends away from the normal. These 2 points have to be very clear in our mind before we go to the next class, okay?